So, like I said, today we're going to be looking at kind of expanding upon that solving the quadratics that we did yesterday, and we're going to look at higher degree polynomials. Okay, so and just evaluating some different using some different strategies for that. Okay, so solving higher degree polynomials. Polynomials. Sound down. There we go. Okay. So, what we're going to kind of do today is kind of build like a tool chest for ourselves. All right. So when we come across some polynomial that we're trying, or a polynomial equation that we're trying to solve, we'll be able to kind of like, kind of identify what tool to use and then use it appropriately, right? But there will be polynomials that even with these tools that we have, we're not going to be able to solve them, right? So it's possible to like create a polynomial that's like not solvable, okay? Or to write one that's not solvable, or at least to write one that won't follow these, kind of tools and stuff like that. So keep that in mind, right? Now, granted, I don't really think I'm going to throw any impossible ones at you because that would just be kind of, I don't know, silly, I guess, in this case. I don't think it's, sometimes I like to throw impossible stuff at you, but for this, it doesn't seem quite appropriate. So anyway, tool number 1, GCF, okay, which stands for greatest common factor. You got it. Now, when you factor, you don't have to get the greatest one at first, right? Sometimes it's a matter of like factoring out just a couple things at a time, maybe, okay, if there's a lot of things to factor. But the greatest one you want to, of course, you want to try and get as much as you can because it just saves you on having to rewrite the problem over and over again. All right, so here's a quick example of that. Let's say we've got like 3x to the 4th plus 10x to the 3rd plus 8x squared equals 0. So what is the greatest thing, the greatest term here that divides all three of these terms? X squared. Yeah, okay. So the biggest thing that divides all three of these is x squared, right? 3, 10, and 8, they don't have any common factors. The coefficients don't have any common factors, but we do with the variables there. So we'll factor out an x squared, and we're left with 3x squared plus 10x plus 8 equals 0. Okay. Is that, and I'm going to say our directions here are to like solve for x or something like that. Okay. Is that the best we can do here, or is there more we could do? Is that as far as we can go? That's the GCF, but sorry, go ahead.
You do the product sum on the inside.
Yeah. So we can like factor the inside, right? It's a quadratic, and we have tools to factor quadratics. Or if we can't factor it, what else could we do to solve that quadratic? Quadratic formula, right? So you always have options once you get it down to a quadratic. In fact, if you can get your polynomial down to a quadratic, then you're good to go. You'll be able to solve that polynomial, right? Because we can solve any quadratic that's thrown at us. If it doesn't factor, we can at least fall back on quadratic formula. Okay? So you kind of have some options here, right? We can then just continue to factor this, and I think I'm going to try. I think this does factor actually, so I'm not going to use the quadratic formula here because I know ahead of time here. All right, so let's see here. If I do, I think 4 here and 2 here, that'll make it work. And now we have 3 things multiplying together to make 0, so we can still use that 0 product property. So that means either x squared equals 0, 3x plus 4 equals 0, or x plus 2 equals 0. So x is 0, x is negative 4/3, or x is negative 2. Okay, and there are our 3 solutions. Questions on any of that? Easy peasy? All right. We'll keep going here then. Another tool, factoring by grouping. Okay, and we saw this a little bit yesterday already. So let's do another one. Here, let's say x to the third plus 5x squared plus 4x plus 20 equals 0. You guys have seen grouping before, I think. So here with grouping, the idea is and typically when you do grouping, you want your terms to be in descending order by power, right? So we have x cubed, then x squared, then x to the 1, and this 20 is technically an x to the 0, right? Because x to the 0 is 1, so 1 times 20 would be 20 there. Okay, so descending order, and then you group. Okay, we'll just group those first two terms and group the last two terms. Right? And if we look at just the first two terms, well, actually, sorry, let me back up one step here. If we consider the problem as a whole first, before I put the parentheses in there, if you consider the problem as a whole, was there a GCF we could take out of the whole thing? No, right? I mean, these three terms have an x, but this one doesn't, and then there's no common factor or anything like that. So there's no whole, there's no GCF we can take out of the whole thing. But if we group, now looking at these first two terms, what's the greatest common factor we can take out of those first two terms? X squared, yeah. And we have then x plus 5. And what about out of the second two terms? 4. And we're left with x plus 5. Okay. And then we can see grouping is going to work here, okay? Because we end up with the exact same factor in each term.
Cancel.
Well, we'll factor them out. We won't say cancel, but yeah, they're going to factor out.
Can you just move the 4 x minus 5 to the other side and it'll be negative? And then x minus plus, or x plus 5 will cancel?
So move it to the other side. You mean like bring it over to the right-hand side of the equation here?
Yeah.
So, well, this is multiplied with x squared. That's multiplied with a 4. So to undo multiplication, we're actually going to divide, or in this case, factor it out like this. So it's x plus 5 times x squared plus 4, like that. It's like this and this kind of gets undistributed back into the front here, and we make that x plus 5 in front of the x squared plus 4. Okay? Okay, but does that make sense? Yes? Okay. I mean, the idea is, right, if you think about it, if I work backwards here, I could take that x plus 5, distribute it to the x squared. I could take that x plus 5, distribute it to the 4, and I'd be right back to there. Yep. So that does redistribute to what we had there. Okay, we're kind of undistributing, if you want to think of it that way. Okay. And so, again, we have a product. It's equal to 0, and so we can set each of those equal to 0. So x equals negative 5, x squared equals negative 4, and so there's not real there. We have one real solution. Now, question. If I had grouped my first two and grouped these second two terms and factored out their GCFs, if I had done that and I didn't end up with the same factor here for each term, would factoring by grouping be helpful? No, right? Okay, and you have to try another method, or maybe check to see that you factored, completely there and stuff like that. But sometimes you'll be able to group it, sometimes you'll be able to factor out of those groups, but then if you're not left over with a common factor, it doesn't help, right? And you're stuck, you need to try a different strategy, okay? Or that strategy doesn't work. All right? Questions on any of that? All right, let me give you one to try. And here, all right, actually I'll just put it down here at the bottom. Or over here on the side. You guys try this one. Okay. 2x to the 4th plus x cubed minus 10x squared equals 5x. Okay. So give that one a try. See what you can come up with there. Question mark? Yes.
I put like 20 of them in there. They can't all be gone.
There's one for you. x squared minus 5? You're going to set that equal to 0. You'll add the 5 to both sides, and then square root, right? So it becomes positive 5. X squared divided by x squared is 1. You're dividing something by itself. Yeah.
Alright. Hey, I undistributed and it just came up with the original problem again.
Interesting. I think you may be distributed then instead of undistributed. But we'll go over it right now so you can see. Okay? Samantha, what'd you do here for the first step? Move the 5x to the other side. Subtraction, right? So 2x to the 4th plus x cubed minus 10x squared minus 5x equals 0. Great, Samantha. Next, let's go to... Lars is getting back. That's not very fair to ask her. She wasn't here. Tommy, what should we do from here?
I mean, you can take out a GCF.
Yeah, let's do that. Well, let's do it, and then we'll get back to where you are too. So anyway.
I got just took out a GCF for x.
Yep, just x is the best we can do there. So we're left with 2x cubed plus x squared minus 10x minus 5 equals 0. Okay, very good, Tommy. Thank you. And then Maddie G, how about from here? What can we do?
Then you can group inside the...
Yeah, so we'll group these two and these two there. All right, so we'll still have that x. Don't forget about that x that's in front. We'll rewrite that. And then what can we take out of these first two terms there, Maddie G? X squared. And we're left with 2x plus 1. And then what can we factor out of these two terms? Negative 5. Very good choice there. 2x plus 1, because we get another positive 2x plus 1 there. Equals 0. Okay. I know these parentheses can get a little bit tricky, but it's actually going to be, good practice. Sometimes we got to, we'll have multiple parentheses and things like that. Okay. Questions so far? We're good? Okay. Keeping on then here. Well, thank you, Maddie G. We'll go to Caitlin. Caitlin, what do you say from here?
Then I just I put them together, so I have them x parentheses 2x plus 1, and then I put the GCS with the 2 together, so it's x squared minus 5.
Okay, yeah, so what was left over from factoring out that 2x plus 1 is the x squared minus 5, and so we have that as a term too. And so we create this one nice big product of three things. Okay, exactly right. And now we have the three things equal to 0. We can set each one of those equal to 0. So x is 0, 2x plus 1 is 0, and x squared minus 5 is 0. Okay, so we get x equals negative 1/2 here. And we get x squared equals 5 here, and so we'll square root both sides. And x equals plus or minus the square root of 5 then. And so those are our 4 solutions. 4 solutions there. Okay? 4 real solutions. 0, negative 1/2, plus or minus root 5. Okay. Questions on any of that? If writing this, if writing this gets too unwieldy, right? If it's too much, you want to kind of make it more simple for yourself. As soon as we have a product, so for example, here we have x times this, right? X times the 2x cubed plus x squared minus 10x minus 5. You can break this up at this point, right? So we could have at this point said, okay, x equals 0. There's a solution, and then said 2x cubed plus x squared minus 10x minus 5 equals 0, and then we'd have to continue on with that. So you can break up, as soon as you have a product and it's equal to 0, you can break each of those two parts of the product up, set them each individually equal to 0, and then proceed. Okay? You don't need to keep it all together and then wait till the end to set them equal to 0. Okay? So you could have done that, and that makes it maybe a little bit easier. You don't have to worry so much about the parentheses and things, but there's an idea for you. Okay? Questions on this at all? Okay. Oh, yes, Jeff.
Wouldn't oh wait, no, never mind, the x, if you multiply the x out into everything, it becomes 2x squared, 2x plus 1 squared.
It would be 2x, if I multiplied x to this right here, you're saying?
Yeah.
If I did that, it would be x times 2x would be 2x squared, x times 1 would be x, so it would be 2x squared plus x. and then you'd multiply that together with that to bring it back together.
But there's two 2x plus 1s. Why isn't it 2x plus 1 squared?
There are two 2x plus 1s. On this line you're saying?
No, on the line before.
Line up here? There are, but remember, those two 2x plus 1s, those are like, you're right, there are two of them. One is with the x squared, one's with the minus 5, okay? So what we're doing here is we undistribute it. So yes, this 2x plus 1 would redistribute to the x squared and the minus 5, but not twice to the x, just the x would multiply it with it once kind of thing.
I don't get it.
So I guess I don't understand what your question is. So you're saying there's one 2x plus 1 here, but there's 2 here? Is that the problem? Right. And so the idea is that these it's in the same principle as when we have a GCF, right? If I have like 5x plus, well, I'll do 5x squared plus 2x. I'll put it up here. Sorry, you can't see it. Both of these terms have an x, right? I could say, okay, that's 5x times x, and that's 2 times x, right? And I pull the x out, and I'm left with 5x plus 2, like that, because the x would redistribute to both of those terms if I wanted to. Same principle is true here with this 2x plus 1. It would redistribute to the x squared and the minus 5, which would be exactly that. Okay?
I think I'll finish understanding it in set today.
All right, well, yep, we'll have some time. I put you in already. All right, so let's go on to another tool we have in our arsenal here, which is substitution. I was like mixing metaphors, I guess, there. Okay, substitution. Okay. So something like this. X to the fourth minus 21x squared minus 35 equals 65. Okay. So first thing, what do we need to do? Subtract the 65 from both sides, right? So you make it equal to 0. Okay. So that would be minus 100 equals 0. So, is there a GCF we can factor out? No. Can we factor by grouping? Well, not really. I mean, you could try and group those first two terms, and there would be a GCF there of x squared, right? But then you'd have x squared minus 21 left over, and then you just have this minus 100 kind of hanging out there. All right? So that wouldn't be very helpful. All right. But what if I rewrote the problem like this? Or what if I wrote the problem maybe more obviously like this? Maybe it's, I hope it's more obvious, maybe not. What kind of format is this problem in now? A quadratic. Yeah, okay. So seemingly here we have a quadratic equation, but it's not quadratic technically, right? It's really x to the fourth. But we can write it and factor it in a quadratic kind of form here, right? We have something squared minus 21 times that same something minus 100 here. And so factoring this problem, well, actually factoring here from the x to the second step, second line, factoring from here is just like, can be just like factoring a quadratic, because we can kind of imagine it and reimagine it in that form there. Okay. So we can use product sum here. We're looking for two numbers that multiply to what? Negative 100, and add to negative, oh, I forgot my 21 there. I was like, 2, there we go, yeah, 21. Sorry about that, folks. Okay? Yeah, so two numbers that multiply negative 100 but add negative 21, those would be what? Yeah, negative 25, positive 4. Okay? So we'll have that same blank minus 25, and that blank plus 4 equals 0. All right? The thing squared minus 21 times that thing minus 100 factors to be the thing minus 25, the thing plus 4. Okay? What are these things though? What are the blanks? What are these blanks that we're missing? What should they be? X squareds, right? Because that's what the perfect square was there. So yeah, these are all x squareds. Question.
Where'd the x squared, like the in parentheses squared go? Not below that?
Right here?
Yeah, the second two.
Right
No.
here. So because remember in a quadratic, right? In the quadratic, the format is something's like the first term is your a something squared minus your b something. Remember the middle term, it doesn't have a square with it, right? It just has to the first power. So that's why I grouped that x squared together as one thing. And so it's really like, if you want, I could put like a to the 1 here if you want,
No,
like
I
that.
was asking like where to go when we did the x squared minus 25 in the first term
Right
or
here?
whatever. You know how it's in parentheses and then it's squared.
Yep.
Where did that squared go?
Okay, sorry, I'm not saying, like you're saying, where did, the square here?
No.
The square here?
Yeah.
So, well, what is, so x squared squared, remember if I were to multiply this back together, it'll be x squared times x squared, which is x squared squared, right? You're multiplying x squared by itself when you refoil it back
okay.
together. We're breaking it apart, we're unfoiling it if you want to think about it that way, okay? And it's weird because we're so used to having x squared, you know, minus 21x minus 100. So, but we can do it with higher powers too, as long as they're, you know, able to be broken down and stuff like that. Anyway, at this point, we have a zero product property we can use. So we'll say x squared minus 25 equals 0, x squared plus 4 equals 0. Okay. You can choose to solve this however you want. If you want, we could factor that x squared minus 25 as a difference of squares, or we can just go ahead and add the 25 over and square root both sides. Either way, we get x equals plus or minus 5 there. Right? And then what about here? What's going to happen with the x squared plus 4? No real solutions there. Okay, so our only real solutions are plus or minus 5. Okay? You could even, if you wanted to, use the quadratic formula for a problem like this. Okay? Except it would not be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In this case, it would be x squared equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So, you could do it that way too. But I won't do that to you right now. All right? So, let's see here. Let's do one more here together, and then I'll have you guys try one on your own. Okay, 3x to the 5th minus 5x cubed minus 12x equals 0. Okay, I'll scoot over. Whoa, there we go. Okay. So take a second or two, ponder it, and I'll call on some folks here to kind of help us out with where to go, what to do, how to start. Maybe like 10 seconds to ponder it there. Think about it. And also I'm calling on some folks. All right, time's up. Here we go. Brendan, what do you say? First step. What do you think we could do here? Ideas. No clue? Okay, so let's just go through our tools here. The first tool we talked about, is there a GCF?
X.
Yeah, x. Yes. And just x, so we'll pull an x out. Okay, 3x to the 4th minus 5x squared minus 12 equals 0. Okay, thank you, Brendan. We'll go to somebody else here. All right, Daniel, what do you say from here? Is there any more of a greatest common factor? I guess we got. Did we get the greatest common factor here, Daniel?
Yeah.
Yeah. Okay. Could we factor by grouping here?
No.
No. So what could we maybe do here instead? Any ideas?
Substitution.
Yeah, we'll do this like kind of substitution method, right? So I'm going to again help us rewrite this. So we'll see 3x squared minus 5x squared minus 12 here. Okay. And again, maybe this will help you here too. the reason why I call this substitution, or why this is called substitution or whatever, is because sometimes we'll do something like this, where we'll say like we'll just come up with a new variable like let u, and we'll let that u be x squared here. And so you can kind of like write this then as x parentheses 3u squared minus 5u minus 12 equals 0. And the idea is that, oh, now we can more easily see it's a quadratic, and so maybe it's easier to factor that way. But if you can factor it from just like here or even here, you know, then you're good to go either way there. So I'll go ahead and factor this though. So Daniel, actually, can you factor it real quick? Do you know?
Yeah, 3x squared plus 4.
Okay. And then x squared
Minus 3.
minus 3. Okay. So yeah, and again, I'm choosing to use the u's here just to kind of, you know, show you that again, you know, changing this helps it look more like a quadratic. So you can see 3u times u gives you 3u squared, 4u minus 9u gives you negative 5, and then 4 times negative 3 gives you negative 12. Okay. But of course, we're not interested in solving for u. We want to solve for x. So I'm going to re-substitute back in that x squared. Okay. Or again, you can completely ignore using the u at all and just factor it as you want, kind of thing. And now we'll set each one of those things equal to 0. So x is 0, 3x squared plus 4 equals 0, x squared minus 3 equals 0. Already have a solution there, and then we'll say x squared equals 3. Okay, so x equals plus or minus the square root of 3 for that. And then what's going to happen here with the 3x squared plus 4? Yeah, so no real roots here or something like that. No real solutions is what I said. Okay. Alrighty. So there's that. Questions on either of those problems there? All right, so let me give you guys one to try. So here's one for you all to try. All right, and this is the last one. We'll get you guys started on your assignment. Bless you. 2x to the 6th minus 19x to the 3rd plus 9 equals 0. Okay, so give that one a try. All right, give that one a try. So, first of all, I guess it's important that you do recognize that this would be like a substitution. You recognize that. Okay, that's important. So the idea then for substitution, typically your goal, for our purposes at least, is to get it to look like a quadratic, right? So your goal then is, you're looking at, I'll just write it up here, okay? You're looking for, in this case, you're going to keep 2, and you're going to have something squared. Minus 19 times something to the first power, right? And then plus 9 equals 0. So what, when you square it, gives you x to the 6th? Not quite. A power to a power, you want to actually multiply the powers. So x to the 4th would be x to the 8th here. to the 4th. There you go, exactly. But here's the problem. Your something is being cubed. You need something squared, something to the 1st, and then your constant, right? To make it quadratic, or get it in the quadratic form, you need, or, you know, that's, yeah, exactly. You have it like reverse or whatever, but that's the idea. Okay, that's kind of the goal here. All right, that gets you in quadratic form. Yes. Yes. Question. Okay. You have, I would say, you have these reversed, and this should be a 3. When you have a power to a power, you multiply the powers. Yeah. Yeah. No. When you multiply, you add. Yes, yes. Because your goal, the goal for these substitutions, Laura, is to end up with a quadratic. And so the outside needs to be squared. Then this. Right. Yeah. You want, because you want to get it into a format that's quadratic. So if 2 is on the outside, the 1 will be on the outside for the middle term, and so on and so forth. Exactly. So now it's x cubed. Yep. Because when you put the cube in, imagine re-multiply. 2x cubed times x cubed, 2x to the 6th is what you got there. Okay? You should always be able to match it back to what you got. Just trying to figure out how it factors.
They just showed it to me. I'm very confused.
Well, so you need, what's that again? So far so good? Yeah, exactly. So I see since that's a minus and that's a plus, that means both these numbers will have to be negative because they multiply to give you a positive, but they're going to add to give you a negative. So both these are going to have to be negative. And so now you have many options. You get minus 3 minus 3, or it's minus 9 minus 1. Of course, you might have to flip, one of those around. Make it negative 19. But it does work. It does factor.
Okay, I understand.
Okay, on this problem here. All right, we're going to go over it. Let's take a look. So, 2x to the 6 minus 19x cubed plus 9, bless you. Okay, this is more complicated, I would say, than some of the stuff we just did, okay, because it's kind of harder to see. But it is a substitution, right? So, x to the 6th is the same as x cubed squared.
X cubed squared.
Uh-huh. Here, I'll zoom in some, Jeff, so maybe you can see it easier. Does that help some? If you can see, can you see it better that way?
I was trying to figure out what the first term was.
Ah, got you.
X cubed squared. That's
Yep.
what it is.
Yep, exactly. And so then minus 19, parentheses x cubed, plus 9 equals 0, okay? And so then we'll factor this thing. Again, maybe it's even more helpful if you just kind of like leave the blanks, or if you want to put a letter in there, like a U or something like that. That's your choice, okay? But I think I can factor it from here. So I'll just say 2, and then that's something, and then that's something here, okay? And let's see, I need to multiply to 9, but add to negative 19. So let's see, I think if I do minus 9 and minus 1 there, and then what's in the blanks? Well, those are those x cubes.
Wait, what?
So the thing we're trying to factor here was 2 something squared minus 19 something plus 9. Okay? So 2 times something plus, and then multiply with that something will give you the 2 something squared. Maybe if I do it this way, it'll make it more sense. Okay? Right here, right? This is what we're trying to factor.
Yeah, but since there's a term for it, why didn't you have to do the AC method?
You can use that if you want to. I just use guess and check. When it comes to like the 2, I mean, your choice. So yeah, we can use the AC if you want to, sure. So 2 times 9 would be 18, right? And then 2 numbers that multiply to 18 but add to negative 19, well, it'd be negative 1 and negative 18, yeah? And then, yep, we can break it apart. 2u squared minus 1u minus 18u plus 9 equals 0. And then we can factor here. GCF would be 2u minus 1. And then GCF here would be minus 9u minus 1. And 2u minus 1. There we go. And so we have that 2u minus 1, u minus 9 equals 0. So yep, the AC method works there still. because you can see what are my u's. My u's are the x cubed. So there's my 2x cubed minus 1, and there's my x cubed minus 9. Did I do it too fast?
I'm just like really confused on the use and substitution.
So all we're doing is like making a placeholder. That's all we're doing here. We're taking something that doesn't really look like a quadratic. We're making it look like a quadratic, right? We're just changing it so that it looks like a quadratic, like this, right? So this 2x to the 6 minus 19x cubed plus 9 is the exact same thing as this equation if we say let u be x to the third, right? If u is x to the third here, then x to the third squared would give me x to the 6, 2x to the 6, right? U would be x cubed, so it would be 19x to the third, and then plus 9 equals 0. So we're changing the format into something that's more, familiar, so that we can then factor it using our quadratic methods. So we're taking something that's not quadratic on the outside, but just doing a slight change of variables so that it does look quadratic, so we can factor it, and then re-substituting back in terms of the x's that we were originally trying to solve for. That's all. So we're translating it to one language to kind of make it easier to work with, and then re-translating back into the original language kind of thing almost, if you want to think of it that way. Okay?
So,
Question, yeah.
Once you make it look like a quadratic, which I still don't get, can you use the quadratic formula?
If you want to, yeah. If that's something you can do that. Okay, so then we get 1 over the cube root of 2, and here we get x equals the cube root of 9. Remember, plus or minuses are not necessary for cube roots, fifth roots, odd powered roots. Okay. So there are 2 solutions. Alrighty. So we'll get you guys started here on your assignments. Okay. The assignment is going to come from the book. Okay. The assignment is coming from our book, but of course you can look it up on the PDF online too if you want.